since 2010. His field of research is advanced energy systems and processes, mainly related to low carbon emissions. He is the coordinator of two running EU-funded projects, namely Biosphera and Fuelforia. His presentation has to do with advanced biofuels for transportation. Uh, Kostis, can you hear us? We can see your presentation perfectly.
Yes,
Uh,
I can hear you.
yes,
I
now
hope
we
that
hear
you
you
can
too.
see my slide. Thank you, Dionis, for the introduction, and thank you.
There might be a slight
Can you hear me? Okay, let's start with my presentation. And I have prepared some slides to present some progress and advances that is doing in R&D level on the production of advanced biofuels that are used for transport as an great effort in order to make the transport sector green, and in order to make to meet EU targets for energy transition there. So, okay. Transport sector is responsible for about one-fourth of total greenhouse gas emissions at EU level. More specifically, road transport holds the lion's share on that, with 71.7% of these emissions in transport, but also maritime and aviation sector also has almost one third of this part. So, and also transport is the only sector that the last years the respective CO2 emissions have increased in terms to contrary to other sectors like industries or household. Given that, EU aims to reduce by 90% of these greenhouse gas emissions are transferred by 2050 compared to 1990 levels. And to achieve that, biofuels will play a crucial role to reduce this emission. And as you can see also in the in the right-hand side scheme, the subsectors of maritime transport section like maritime and aviation, as called as hard to abate sectors, because for technical reasons they cannot other solutions for decarbonization like electrification or using of hydrogen cannot be applied at large scale applications. And so for that cases, for that subsections, biofuels are expected to play very important role. This slide presents an overview of different pathways for the production of different kinds of advanced biofuels that can be used potentially at different transport sector, starting from the feedstock like different oils like vegetable or animal fats or oil from algae or organic waste and bio waste, and last but not least the lignocellulosic biomass. There are several different options to convert them into a medium like lipids through recovery, or sugars or biogas through hydrolysis and digestion, or syngas through gasification. And this intermediate product, after upgrading, they result into the different kind of fuels that like HEFA, biodiesel, CNG, biomethanol, etc. that can be used at certain applications in aviation, maritime, and road and heavy road applications. Apart from these pathways and that are dealt with the valorization of biomass and sustainable biomass like biogenic residues and waste, there is also another option to produce renewable synthetic fuels using carbon dioxide from low carbon applications like biogenic bio-based industries or other biogenic derived carbon dioxide. Again, this in that case, carbon dioxide can be converted into either or syngas or lipids, and then and almost the same list of fuels can be produced through catalytic, biological, and other processes. Now, in this presentation, I'm going to present the progress that has been done in four interesting European funded projects that deals with the production and the development of new pathways and processes for the production of the advanced biofuels and renewable synthetic fuels. And in that slide, I summarizing the pathways that I'm going to talk later now. Starting with the first project, which is Biosphera. Biosphera is a project that deals with the production of drop-in biofuels for aviation and marine applications through a novel and combined thermochemical and biochemical pathway. The main goal is to develop this new concept that I'm going to describe in detail in a while, based on a two-step biological process that converts syngas from biomass gasification to microbial oils, and these oils undergoes hydrotreatment, and the final product is hydrotreated triglycerides that are consist the final product that can be regarded as a drop-in biofuel. The key and the benefits of this process is the fuel flexibility, because the biomass technology that we employed has proven ability to valorize different kinds of biomass feedstock from different origins. The minimization of gas cleaning steps because of the ability of the microbes to sustain under under certain impurities that exist in the syngas, the low OPEX, and enhance the yields of the target biofuels. Our role in this project is, first of all, we were the project coordinator. I say were because this project ends last March. We undertook the characterization and analysis of the feedstock and the selection of the most promising of them. The process simulations through Aspen Plus software, numerical simulation through CFD analysis, and lipids hydrotreatment at both lab and pilot scale. And of course, and also the key horizontal activities like techno-economic and environmental evaluation through TEA and LCA analysis. I would like to present the overall concept. The concept starts with the different kinds of biogenic feedstock, like agricultural waste, forest residues, industrial residues, and waste from biogenic origin. And this solid feedstock are converted into syngas through an dual fluidized bed gasification. This type of gasifier does not need pure oxygen to operate, so in that case we get rid of the necessity to build an cost intensive and energy demanding air separation unit, and produce raw syngas after very specific and certain gas cleaning steps like tar removal. is the feedstock for the production of the new type of oil, which is microbial oil, through a novel two-step biological process, where in the first step, syngas is converted into acetate through an anaerobic fermentation using acetogenic bacteria, and the produced acetate is the substrate for the production of microbial oil using engineered strains from of oleaginous yeast within in a aerobic fermentation unit. This soil is exists initially within the cells of the yeast and undergoes purification and extraction through a series of different lipid purification steps. And the microbial oil that is purified is sent to a hydrotreatment reactor where through catalytic conditions under high pressure and temperature is converted into paraffinic compounds and alkanes that this after fractionation are the basis for the production of the final product, which are the biojet fuel and diesel-like biofuel, bunker fuel. And through these 4 years of the project, we managed to perform lab activities in the overall value chain of the process, starting from the gasification up to the final product, the final liquid fuel product at the lab scale. This activities were important in order to optimize its
Costis, I don't know if you
step,
can hear us.
and based on the scale. I don't know why. I can hear you. Can you hear me?
Yes, there was a minor hiccup. If you could just repeat the last 10 seconds of the like just this page.
Ah, okay. Okay. In a nutshell, yes, I would like to show that through this during these 4 years, we aim to perform the necessary lab scale activities in the overall value chain, the whole value chain for the optimization of the process parameters in each step. And based on that, we perform the pilot activities at TRL5 in the overall value chain as well. And some key facts from this project that ends last month is that we successfully perform a gasification and gas clean and gas fermentation pilot campaigns and aiming to we managed to produce acetate with a production rate of 0.77 grams per liter per hour. We proved that the less syngas cleaning step than thermocatalytic pathways like Fischer-Tropsch synthesis are required. The lipids production, we perform liquid fermentation tests with three different substrates like acetate, glucose, and glycerol, and we're achieving and quite good rate of 0.26 grams per liter per hour. Very important is that no intermediate purification step is needed between the acetate production and the liquid fermentation process. From the energy analysis and the techno-economics, we estimate that the overall plant energy efficiency was at 35.6% of energy, and with almost 27% of total carbon utilization, where the minimum jet fuel selling price was estimated at 1.83 euros per liter. From the environmental analysis, we estimate that this process is able to achieve greenhouse gas emission savings from 48 to 86% compared to other conventional fossil fuel. And in the most environmental case, we aim to achieve an, CO2 emissions at 15.5 grams CO2 equivalent per megajoule of fuel. And the key added value, the legacy that this project leaves is that it introduced a new sustainable feedstock for HEFA plants, because this is a new kind of oil that can be easily used as the feedstock for the production of hydrotreated vegetable oil in already using already commercial technology of HEFA. The biosyngas fermentation runs were performed at pilot level for first time ever. They produce biofuels through microbial oil hydrotreatment were done for first time ever, and new strains through the engineering using specific engineering tools were constructed that managed to produce lipids with advanced performance. And we expand the portfolio for producing microbial oil using different sources and substrates like glucose, for instance, coming from biodiesel, and glycerol from biodiesel, sorry, and glucose from second generation cellulosic ethanol plants. The second project is called Clara, and this project mainly scope was to develop a new and a chemical looping gasification technology where the producing gas was the basic for the production of Fischer-Tropsch liquids, and employing and valorizing biogenic residues at a large pilot unit of 1 megawatt thermal. According to that concept, the biogenic residues with similar origins like the previous one project undergoes to pre-treatment and gasification through this quite novel chemical loop gasification technology. The production of syngas is into an Fischer-Tropsch reaction for road transport fuels production. And before that, a novel syngas treatment technology through acid gas removal was developed as well. Our role in that project was to perform the simulations at the steady dynamic conditions, and also to perform the WOX hydrocracking test. WOX was the Fischer-Tropsch synthesis process. This project ends in March of 2023, and the coordinator was the Technical University of Darmstadt from Germany. This is the process flow diagram of this concept, starting from the biomass pre-treatment using a portfolio of different methods like drying, leaching, and pelletization. The treated biomass enters the dual fluidized bed of the chemical looping gasification. And in that technology, the aspect that makes it different from other technologies is the fact that the oxygen that is needed for the oxidizing medium that is needed for the gasification reactions is not coming from air, but from circulating solid oxides that are oxygen carriers, that at first they react with air in a different reactor, and get the oxygen from the air, and then they are sent to the fuel reactor, where the oxygen reacts with the vapors from the coming from the fuel devolatilization. The raw syngas undergoes to a certain different gas cleaning steps for the removal of all the impurities that may harm the catalyst performance of the Fischer-Tropsch synthesis. And there the FT crude is produced under catalytic conditions and in high pressure and temperature. And the final step is the heavy fraction of waxes undergoes hydrocracking for the production of more valuable products like diesel and gasoline fraction. That also enhances the overall yield of the desired products. This is the schema of the respective activities that were carried out in this project.
Sorry, because this, I'm just let you know, we're a bit past the 15-minute mark.
So, would like to finish my presentation or to skip to make it faster?
No, you just prioritize what is more important, or of course, if you're like towards the end, please go ahead and finish normally.
Okay, okay. I'm yes. The third project is the Flex Energy with the project coordinator. There is VTT from Finland. The idea is to develop a flexible and cost-effective gasification-based process for the production of biomethane that has the ability to has a pipeline quality that can be used at various purposes, and high-value biochar and renewable heat from using a wide variety of biomass residues and biogenic wastes. The key aspects and the benefits of this concept is that this gasification concept is able to switch between different operation modes, either maximizing the biomethane production or perform produce both syngas for the biomethane production and the biochar. Where our role here is to perform the design and model development of the overall concept, the CFD simulations analysis, and the analysis from economic and environmental point of view. I don't want I will not get into more details about the concept. Maybe if someone asks later, I will get more detail. The only aspect I would like to mention is that through this topic, through this concept, the aim is to minimize the cost at different steps that exist in state-of-the-art bio-SNG value chain, like the elimination of water gas shift, the minimization of oxygen demand, and the introduction of an innovative new oxygen membrane, transport membrane technology, aiming to achieve a cost saving of around 30%. And also, very important is also the methanation technology that we are employed that simplify the overall process and minimize also the final biomethane purification steps. And the last project is Fuelphoria project, which is a new Horizon Europe project that aims to demonstrate a portfolio of different technological solutions for the production of both advanced biofuels and renewable fuels with no biological origin, using sustainable feedstock and renewable energy. That sustainable feedstock includes residues and waste, CO2, and the portfolio of the different state-of-the-art technologies that we are developing is from different domains like biochemical, thermochemical, photobiological, electrochemical, etc. The products that are produced will be used for transport and power sector, and also the certain methodological analysis and is developing in order to maximize the exploitation of the overall concepts and to foster these advanced biofuels technologies at the European and level. Our role here is we are the project coordinator. This project consists of 26 partners. We are also have the general overview of the demo supervision and the pilot operation, and also are in charge of performing the technical evaluation of the demo results. This is the overview of the demos. Four demos are developing in two in Spain, one in Greece, and one in Belgium, and aiming to produce fuels that mainly are gone their destiny is to use that for to cover transport needs in aviation, maritime, road transport as well. And yes, okay, I said previously that among the feedstock is biogenic CO2 from winery plant or from biogas plant, and also organic urban waste from a waste treatment plant. And my last slide, the conclusion of my presentation. New technology, as seen through these four interesting projects that have been funded by EU, there are several new technologies with upgraded specifications in terms of performance and feedstock flexibility that make the advanced biofuel the target of decarbonization. Biomass is very important to know can play very important in meeting the demands for sustainable transport. There are several advanced technologies that offer the possibility to utilize the different carbon source for the production of advanced renewable fuels, also with the use of green and renewable hydrogen. There are several high expectations for biofuels, and we expect to have a leading role in transport, especially in aviation. And also our organization, CERT, has a very active role in through our involvement in several EU-level research efforts to foster and to develop these technologies for the production of advanced biofuels. Thank you very much, and I'm also like to